Hey guys, it's Mike from SimSystem, and today I'm going to show you how we import and process hybrid or screw-retained abutment cases. Now these are cases that involve the use of a titanium base, and it could be in either zirconia or PMMA-like materials. For this particular example, we're going to select zirconia today, and I'm going to go ahead and import a couple of these cases for us to look at. Now, screw-retained or hybrid cases I consider as having tie bases or titanium bases that are going to be cemented internal to these. Now, these are typically not going to be hexed or trilobe engaging interfaces, and they're typically going to be designed with the geometry of a ball nose tool kept in mind. And this could be a hybrid abutment like I've kind of shown you guys, or this could actually be a screw-retained crown as we're showing here, where the abutment and crown are not separate but are instead one full piece. So for this example, I'm going to import two screw-retained crowns, and we're going to select these as a hybrid abutment during import process. Now the reason I've selected hybrid abutment and not abutment or anatomic abutment bridge is again because these are not hexed or trilobe engaging interfaces. The one exception to this is if you're having trouble processing a case as a hybrid abutment and it's a conical shaped interface, then in that particular example you could also try importing it as an abutment or an abutment bridge to try and move that further. Now in this particular case I have a minimum thickness required of 16 millimeters, so I'm going to select from one of my 16 millimeter discs that I have available here, and it's going to simply import and nest these parts just like so. So I've got a couple of different visual layers turned on, and you may notice more items on my screen than on yours. I'm going to explain what each of those are and how those will impact the finished job. Now the very first thing I notice is this pink arrow that's kind of pointing down at the restoration here. And when I click on it, what this is actually showing me is a secondary insertion direction that was detected. Now typically this is going to be more for single unit hybrid abutments that are going to have like a top cap for a crown to go on top of. And that may be like an angulated top cap. In this particular example, this is just like a screw-retained crown, so I don't actually need that secondary insertion direction. So I'm going to go in and first get rid of that. I'm going to do that by going to Tools and clicking on Curves and Surfaces. Once I've done that, I can click on Delete Curves and Cylinder Caps and simply click on that arrow to get rid of it. So there's no additional secondary insertion that we need to come in and finish this restoration from. We're just going to have it come in and do it like 3+2. So at this point, there are three criteria to processing screw-retained or hybrid abutments for milling, and if you follow these steps, they're going to ensure that you get over a 95% success rate on these parts coming off the mill. Majority of issues stem from people not really understanding what these curves or surfaces are intended to be used for, and so that's what we hope to explain with this video. So the very first thing that I typically do when I'm looking at these cases and whether or not everything's properly designated is I'm going to turn a transparency on. So this is the number 9 key on your keyboard that you can use, and when you tap that once, it's going to show you the parts but transparent, where you can kind of see through those. If I hit the number 9 key on my keyboard again, it's going to show me the mesh of those files. If I want to get back to normal, I can hit the number 0 key on my keyboard, and that'll simply get rid of that additional rendering mode. So when I hit the number 9 once, we can see that I have all of the surfaces and some curves that are present here. Now, the curves based on your version may display differently, different colors. And when I refer to curves, I'm talking about lines. So you can see some are magenta here, and that's majority. For majority of people running on 2018 or earlier, these are the colors that you're going to see. All the curves will kind of be the same. As of 2019, we have two curves that are present here, the drilling axis and the margin line, and the drilling axis is defaulted to green, and that curve line or the prep line or margin line is designated as a pink curve. So let's get into the requirements for this case to process out properly. Well, the first requirement is that these red caps need to be present at the top and the bottom of the access channel. And the reason that those curves are even there is very specifically for the roughing and the finishing tool pads. So we don't want those going into this internal area to the access channel, because those tool paths are not made for drilling. So you could have a situation where the tool dives deep into that access channel, and because of that, you could either break a tool or you could break the sidewall of the part out and kind of have to start over. So that's one thing that's very important, and it needs to be, again, at the top and at the bottom of the access channel. Now, very important here, if the curve is not at the bottom, like in this case it's slightly up, that's fine. It can be up inside of the access channel. What I would say is if it were very much deeper, like if it were another 1 or 2 millimeters deeper, I would probably want to designate that closer toward the bottom. But this is even more important, is if this red cap is lower, like say it's actually down inside of the area where the tie base would sit. Well, I would want to delete that and recreate that as well, because if it's down here and it stops the roughing and finishing operation, that means that from this point up, I would have a bulk of material that just didn't get milled out because of that red cap. So we want to make sure that we're placing those surfaces, the temporary surfaces, in the correct location. So next question could be, what if those curves are not or those surfaces are not present at all? For example, I'm going to go in and actually delete these out using curves and surfaces, and delete curves and cylinder caps. I'm just going to select on the red caps so that way those are gone. And now we can see that even with transparency on, we can see that the part itself does not have those properly designated surfaces. So we need to fix that. The only way to do that is go to Tools, Curves and Surfaces, and click on Add Cap to Cylinder. Now the way that this algorithm works is you need to select the inner sidewall that most resembles a full cylinder. So you wouldn't want to select up toward the top here, because we don't really have a full cylinder kind of going across. And so in this case, I'm going to select down inside of the access hole and simply click in there. And once I've done that, we can turn the transparency on and kind of zoom back out, and you can see that it's replaced the access or the temporary surfaces at the top and the bottom of this access channel. Now, one thing to note is that it is slightly lower, but it's down at the bottom of the access channel, and it's not inside of the prep area or the tie bases area. Again, this is very important. This is okay. Even earlier where it auto detected slightly higher, that's okay. We just don't want it any lower than the bottom of the access channel. Again, if we put it lower than the access channel, we're going to have an issue, because we're going to have material that won't be milled out from the inside during the processing stage. So we've kind of gone over the first criteria, which is having those red caps in the correct locations. The next criteria that we're going to talk about is having this drilling axis curve present. So again, in the older versions, it's going to be magenta in color, but in 2019 and up, we're going to show this as a green curve that goes all the way down through the bottom of the access hole. So the importance of having this information present is the drilling operation uses this not only to detect the axis it needs to drill from, but also to detect the milling depth and the width or diameter of this hole. So a couple things that we can do adjustment wise is when we can go to Tools and Curves and Surfaces, and then we can actually click on where it says Change Cylinder Size. So for some reason, if this did not go the full length of the access hole, and let's say that it stopped right around here, we can actually change the length of this access hole by going to Change Cylinder Size and clicking on the curve that we want to affect. So this is the curve. And we can see some information here at a glance. So we can see our diameter is listed here as 3.188. So if I had a need for a larger or a smaller access channel, I could actually come in here and adjust this value, maybe make it 4 millimeters as opposed to 3.188. Now you'll actually see on the screen in 2019, we actually show this green cylinder. So as you're making the changes, you can kind of see what changes you're affecting here. And also if you need to lengthen this screw axis channel out, like say I want to go from 10.15 to 12, I could do that, and we can see that the drilling operation is going to go a little bit lower. Again, this is on 2019 where we kind of show this green cylinder, kind of showing how you're going to affect this tool path. But one thing we want to keep in mind when we're placing values in here manually on the length is just make sure that your tool has that reach. Some tools don't have a neck reach that go beyond 12 or 13 millimeters. And so we want to make sure that we're not trying to tell the tool to go deeper than it has the capability to do so. Otherwise, it's not going to be able to mill this access channel out. So once we've verified these settings, we can simply click the check mark to confirm those and then get out of this tool to be done making adjustments. Now, what do we do if the red caps, if the drilling axis curve is not present at all? So what I'm going to do, I'm going to toggle the red caps by using the Control-R key on my keyboard to turn those off, at least just from the visualization. And additionally, I can go to Tools and Show and Hide, and there's a button here for Show or Hide the Holes, which will turn the red caps on or off. What I'm going to do here is I'm actually going to delete this curve out because I want to show what we do if the curve just doesn't get detected. So when I double click this button, it actually turns off the rendering, which makes it easier for me to see the curves, and I can just go in and select the one that I want to get rid of and just simply click the tool when I'm done using it. So in order for me to detect the cylinder hole, just as it has been designed, is I can go into cylinder detection and simply, again, using the same algorithm as the Add Cap to Cylinder button, we're gonna click on a part of the sidewall or the cylinder where we most have a full cylinder going around. So I'm going to click on that, and that now has created that axis that we're going to be drilling along. So we can see there's our drilling axis and that it goes the full length of the access channel, and that's good. So we've now kind of covered the first two criteria of what we need to be on the lookout for when we're processing these cases. So the third and final criteria is down here at the bottom or the base of the abutments. What we want to verify is the following. We want to verify that the margin line or the prep line curve is present at the base of the abutment. Well, on 2018 and earlier, the only way to do this is to turn on the visualization for the caps over the margins. If I do that, I can go to Tools and Show and Hide, and I can click on Hide Cavity or Show Cavity to turn that layer on or off. Now this layer, this gray cap, gets placed in order to keep the roughing operation from going inside during the first tool path. But additionally, it gets created based off of where the margin line curve is present. So if there is no margin line curve, which in my case, since I'm using 2019, shows up as pink, then that surface will also not be present. So I'm going to go in and just delete that out. And now we can see the difference between a properly designated case on the right here versus one that still needs a little bit of work. So if I need to designate the margin line curves here, I can go to Tools, Curves and Surfaces, and using the same tools as I would on Crown and Bridge, I'm going to go and do margin line detection. Simply click close to where that margin would be and set a thickness. 0.15 is okay for your abutment cases. And we're just going to give it a second here to auto-define that and designate that curve or the prep line around there. And you can see that once it's detected, it automatically recreates that gray cap and simply closes that area off. Now, again, if you're on the 2018 or earlier versions, you're not going to see this pink line. It'll be magenta colored, just like the other curves. However, you can still go in to Show or Hide Cavity, and that will give you an indication of whether or not the curve is the correct one and whether it's been placed in the correct location. Now, if it places the gray cap like far up inside of where the tie basin area should be, then that's not been designated properly. So you would need to delete those curves and come back in and redesignate them just like I did. So those are the three criteria to ensuring that your cases are properly prepared before they get sent over to the mill. And I would say that 95% of cases can enjoy a high success rate by following these three main steps. Additional, if there's for some reason if you're having trouble detecting these curves or designating these features, one thing that I would encourage is after your calculation step, just make sure to go down here to your simulation and check the result of that. So kind of the last steps that I would do prior to actually sending this to the mill, because I can see on this particular part I do have some undercuts in this area. Now there's two ways I could tackle that. I could increase my offset, but that increases my part border kind of all the way around the part. And I don't really want to do that. An alternative is I could just kind of open it up to the kind of the open face between these two parts, and then intersect my part borders like this a little bit to give the tool a lot of clearance to kind of be able to cut these undercuts out, both from the 0 and from the 180 side. Basically, I've kind of removed the obstacle of having the part border around the part itself, so that way I don't have an issue when clearance-wise when I'm trying to get that tool inside. So that concludes everything that we need to do to get these parts ready for the mill. Maybe one other thing is I'd place another support pin on the far side of this crown because it's a pretty big one. And now I'm going to get ready to get this over to the mill. So I'm going to click on Save Toolpath, and we're going to get some options that come up here. Now I'm going to do the 5-axis simultaneous just because it takes a little bit longer to calculate, but it runs faster on the machine. And I don't have a whole lot of undercuts to be milled, so this one will work just fine for that application. In this particular instance, I also have some detailed anatomy that's been designed into these crowns. In this one in particular on the right, we can use both a 0.6 and a 0.3 to mill those details out. So at this point, the calculation is going to commence in the background. I will be presented with one final window, which is just going to let me know what slots each of my tools need to be inserted into. We can always quickly kind of confirm that dialog before we actually upload the file on the mill. One of the cool features of 2019 is this is actually calculating and processing in the background. So even if I were to walk away at this point, the CAM process would continue through until the calculation is complete. So again, here's our tool slots on the left and a description of the tool on the right. And as long as we make sure those are in the correct slots, we're good to go and send this to the mill as soon as our calculation is done. So I can hit the check mark here, and then once that pops up, we're good to go. So this has been our workflow video for hybrid abutment cases and screw retained, and hope that this helps you guys out from a technical standpoint. Again, I think if you guys follow these steps in particular as you're processing all of your hybrid cases, your success rate is going to be much higher coming off of the mill. Thanks for watching, and make sure you guys follow us on YouTube and also on social media on Facebook. We have a MillBox experts group that is a really good place to come in and ask any questions that you may have about the software or just to share experiences that you've had. Thanks again for watching, guys.